12.6 is all about composite functions. Composite functions mean that you have one function that is put inside of another function. Okay, so you plug a function into another function instead of plugging a number into another function. So it's a lot like substitution. Okay, they look pretty complicated, but they're not as tough as they look. Okay, so just take them one step at a time. Okay, first off, composite functions are written with a new symbol that you may not have seen before. It kind of looks like the degree symbol, except it's in the middle instead of up above. Okay, so the of symbol looks like this. Okay, so you say that of. Okay, what do you do with it? What it means is that you take the whole second function, whichever one shows up on the right-hand side, and you plug it into the first function instead of wherever the x's would be. Okay, so we practice plugging numbers into functions. You're going to take a whole function like an equation and plug it into the other one. Okay, you're not going to plug in equal signs, but you will plug in terms. Okay, the next line, f of g of x. Okay, that's written a couple different ways. So f and then the of symbol and then the g of x. And that's the same thing as the second function, which is g, plugged into the first function, which is f. So here it shows we have the f function on the outside. Okay, so that's this whole part. And then on the inside, we're plugging in g. Okay, g was the second one, and f was the first one. Notice that that first letter stays first, and then the second letter, that's the function that gets put inside. Okay, so you plug g of x into f of x everywhere there was an x. Okay. The next type of function is g of f of x. So notice that's just the opposite order of what we had before. Okay, so it's the opposite order here. Instead of f of g, we have g of f. Okay, so f, which is your second function, gets put into g of x everywhere there was an x. So f is now the inside function, and g is the outside function. Notice that anytime we put one function into a different function, we used parentheses. Be very, very careful of that. Every time you get rid of an x to put in a new function or to put in even just a letter or a number, make sure you are using parentheses. All right, let's try a few examples because it looks super weird, but they're not as bad as they look. These are problems we will not be able to use a calculator for the most part, because we are plugging in just like an x or a function instead of just a number. Okay. Example 1, we have f of g of x. Okay, so f was the first function. It's going to stay on the outside. So we're just going to rewrite this in another way. F of. Okay, so that was our first letter. The second letter, the second function, g of x, goes inside. So f of g of x. Okay, so we are going to rewrite the outside function, which is f, but everywhere we have an x, we're going to put a set of parentheses. And inside that set of parentheses, we're going to put g of x. Now, notice that g of x has two terms, so make sure that the parentheses that you draw is kind of larger than normal, because we're not just plugging in one number, we're plugging in two terms. Okay, so f of g of x, we're rewriting the first function, f of x. So that's going to be 3 times, instead of x, and then minus 4. Okay, because f of x is 3x minus 4. So far all we've done is instead of x, we're putting a set of parentheses. Okay, so it's like f of something is 3 times something minus 4. Okay, now instead of the x, we're going to put whatever is inside that set of parentheses, which is g of x. Okay, so this says 3 times g of x minus 4. Okay. Now g of x is a function itself. G of x is 7x minus 2. So we can replace g of x with 7x minus 2. And now your job is to simplify this as much as possible. Okay, so it looks to me like we have a number on the outside times 2 terms on the inside of that parentheses, so we can go ahead and distribute. 3 times 7x is 21x. 3 times negative 2 is negative 6. And then we can bring down that minus 4 that was already there. Okay. Then we can combine like terms. This is our first term, 21x, and it doesn't have anything to combine. And then negative 6 minus 4, they have the same sign, so you add them together, is negative 10. Okay, so f of g of x is 21x minus 10. All right. Example 2, we have g of f of negative 3. Okay, so our first function, our outside function is g. So this is going to be g of, and then f is inside. Oh. Let's start over because I'm just rewriting it the exact same way. Okay, so this is g of f of negative 3. So every time you've got a parentheses with something inside another function, you are using the word of. So this time we're going backwards. So instead of g of f of x here, we're trying to write it as g, and then we use the little O symbol, the of symbol. Okay, so this is g of f, because f is the second one. G of f of, and then negative 3 is after it. Right? First letter, second letter, what is the thing that is on the most inside? Okay, what number are you evaluating at? This, I think, is the easiest way to look at it because you can see what is your outside function and what's your inside function and what are you plugging in. So first off, let's figure out what is g of f of x, and is that the same thing as f of g of x, which is what we did in example 2. Okay, so g of f of x. And then we'll plug in negative 3 once we get that simplified function. So g of f of x, what is that going to equal? Well, g of x is 7x minus 2. So this is going to be 7, but instead of the x, we're going to put f of x, and then minus 2. 7 times whatever you're putting inside, minus 2. Okay, let's rewrite. So this is 7 times something. What is f of x? F of x is the function 3x minus 4. And now we're going to distribute. 7 times 3x is 21x. 7 times negative 4 is negative 28. And then bring down the minus 2 that was already there. Okay, combine like terms. 21x doesn't combine with anything, but negative 28 and negative 2 add together to get negative 30. Okay, so one of our questions was, is g of f of x the same thing as f of g of x? And the answer is no. On one of them we got 21x minus 10, and the other one we got 21x minus 30. Okay. So this is g of f of x. We want g of f of -3. So it's g of f of x. We want g of f of -3. So we're going to take -3 and plug it everywhere that we had an x to begin with. We've been doing these types of things all chapter, where we just take the number and plug it in and then simplify. Okay, so this is going to equal 21 times -3, which is -63, minus 30, which is -93. Okay, so this was g of f of x. This is g of f of -3. All right. Number 3, we want f of x. Okay, so let's find a different way to write it. I'm still going to use 2 colors, even though this is f and f, just so we can see where everything is. Okay, so our first function is the letter f. This little O of symbol means that we are plugging the second function into it. So f is our inside function. And then this last little piece says what is inside the second function, which is just an x. Okay, so f of x is just 3x minus 4. So we are plugging in everywhere there was an x, we're plugging in something different. Okay, we are going to be plugging in f of x because that's our inside function. F of x, f of x. Just copy down. Okay, on the left, this part doesn't change. This is still just f of x. But on the right, we don't want it to say f of x. We want it to say what the function actually is. So f of x is 3x minus 4. And then we can work this out. Distribute. 1 term times 2 terms is 2 terms. So we get 9x minus 12 minus 4. And then simplifying 9x minus 16. We are not plugging in a number, we're leaving it with an x. Okay, last one in this set, we're doing h of f of x. So h is our outside function. It goes first, so we keep it first, h of. F is the inside function, so here's the f. Okay, and then x was what was plugged in, so that goes last like this. So we're kind of rewriting it backwards. So this is the most obvious way to write it, where you have h of x and you're plugging in f of x. So first off, what is h of x? It is 5x squared plus 2x minus 1. Okay. So everywhere we see an x, we should be putting a set of parentheses instead of the x. Notice I said instead. That's one of the most common misconceptions on these problems, is students leaving in the x and putting in a set of parentheses with a new function. So watch how all of the x's just completely disappear. Something squared plus 2 times something minus 1. So everywhere there was an x, now there's a set of parentheses instead. Okay. And then inside each of those spots, we're going to put f of x. All right, here we go. H of f of x is 5 times. We need a spot for 2 terms inside that parentheses. All right, on the left, we're going to keep the f of x just because we're talking about certain functions. But on the right-hand side, we want to actually plug in the equation part of f of x. I guess it's an expression, not really the equation. So f of x was 3x minus 4, and then 3x minus 4 here as well. Okay. PEMDAS, order of operations, says that we need to square this set of parentheses. I'm going to do that on a separate piece of paper just to save some room. So we are doing just the 3x minus 4 squared. Just this portion right here. So squared means that we are multiplying a set of parentheses times itself. Okay, this is a binomial squared. You may have learned a pattern. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Negative 4 times 3x is negative 12x. And negative 4 times negative 4 is positive 16. And then we're going to combine like terms, which are these two middle guys. So we have 9x squared minus 24x plus 16. Okay, so where we had this piece in our function, we're going to substitute that out and replace it with this in parentheses. Okay. So h of f of x is 5 times those 3 terms. The 3 terms we just got were 9x squared minus 24x plus 16. All right, let's keep going. Plus 2 times, and then minus 1. 2 times 3x minus 4. Okay, this problem has a whole lot of distributing and then combining like terms. Okay, let's take it one step at a time. I'm going to stick with one color from here on out. So h of f of x equals, all right, 5 times 9x squared is 45x squared. 5 times negative 24x is negative 120x. 5 times 16 is 80. Okay, so that was all of this. 1 term times 3 terms is those 3 terms. Okay, move on over here. 2 times 3x and 2 times negative 4. So 2 times 3x is 6x. 2 times negative 4 is negative 8. And then bring down that little negative 1 at the end. All right, our last step is combine like terms. Start with your biggest exponent, which is a 2. So 45x squared. You know, anything that has an x. We have a negative 120x and a positive 6x. That is negative 114x. And then we have 3 constants, positive 80, negative 8, and negative 1. So that adds up to get 71. Okay, this is in standard form, biggest to smallest exponent with your constant at the end. Our original problem said to just leave x in our answer, not plug in a number, so we are done. All right, number 5 is a couple of different questions. It tells us that f of x is 4x plus 1, and g of x is x squared minus 2. Which of the following is an expression for f of g of x? And then what would g of f of x be? So we saw in examples 1 and 2 that f of g of x and g of f of x do not give us the same thing. Asterisk, usually. There's a rare case, and it has to do with inverse functions, where f of g of x and g of f of x are the same thing. It's pretty rare, and I don't know, maybe we'll see it, maybe we won't. Let's find out. So let's start with f of g of x. I'm going to do that over here on the left. F of g of x. Okay, that means we're going to rewrite the function f of x, which is 4x plus 1. But instead of the x, we're going to put g of x inside. Okay, g of x is x squared minus 2. So in that parentheses, replace the g of x with x squared minus 2. And then we're going to distribute and combine like terms. So 4 times x squared is 4x squared. 4 times negative 2 is negative 8. Bring down the plus 1, and we get 4x squared minus 7. Okay, so that would be answer C. Let's take a look at g of f of x. So that's going to be the same thing as, okay, g is our outside function, so that's the one we're writing first. It is x squared minus 2, so something squared minus 2. What's getting squared? Instead of x, it is f of x. Okay. We'll rewrite, but instead of f of x, we're going to put the actual function, which is 4x plus 1. And since we're squaring a binomial, a set of parentheses, that means we actually have to multiply it out. So this is going to be the same steps that we did on that note card. I'll just write it out here though. 4x plus 1 times 4x plus 1. And then that little minus 2 just kind of hangs out there. Okay, distribute. 4x times 4x is 16x squared. 4x times 1 is 4x. 1 times 4x is 4x. And 1 times 1 is 1. Bring down that minus 2 that was already there. And then we combine like terms. 16x squared does not have a like term to go with it. 4x plus 4x is 8x. Remember that when you're combining like terms, you do not change your exponents. And then 1 minus 2 is negative 1. So that is answer option E. Okay, so we have proven again that f of g of x and g of f of x are not the same thing.